In today's video, we are going to cover section 3.1, what are congruent figures. After studying this section, you'll be able to understand the concept of congruent figures and accurately identify the corresponding parts of figures. So congruent figures. In general, two geometric figures are congruent if one of them could be placed on top of the other and fit exactly, point for point, side for side, and angle for angle. So one figure is the exact replica of another figure. Now, congruent figures have the same size and the same shape. So every angle will have the same measure and every side will have the same measure. Now, when I look at congruent figures, more specifically congruent triangles, I have what's called a congruent statement. So I know that every triangle has 6 parts, 3 angles, and 3 sides. Now, if I look at my congruent statement, this tells me triangle ABC is congruent to triangle FED. Now, this congruent statement will tell me which angles are congruent to one another and which sides are congruent to one another. In order to have the correct congruent statement, I need to have each letter of each triangle match with its corresponding part of the other triangle. So notice, if I have triangle ABC congruent to triangle FED, A comes first, F would need to come first because in my diagram, A and F are the same angle. So when I look at my congruent statement, I know that angle A is congruent to angle F. Then, if I look, my next is angle B and angle E. Angle B and angle E are congruent, so they would come next. Then I would have angle C and angle D, because those are also congruent in my diagram as well. So that tells me that angle A is congruent to angle F, angle B is congruent to angle E, and angle C is congruent to angle D. Now I can also match up my sides. So my sides would just be the two that are connected. So AB should match with FE. And again, in my diagram, AB matches with FE. Then I can say that BC matches with ED, which again, in my diagram, it does. And then my last side would be AC with FD. And that also matches in my diagram. So my congruent statement, even if I don't have a diagram, will tell me which angles and which sides are congruent. So notice if I had triangle DEF here, this would be an incorrect congruent statement, and I wouldn't have congruent triangles because angle A does not match with angle D. Now this leads me to two definitions, congruent triangles and congruent polygons. Now this double arrow symbol means a reversible statement. So I can have my if first or my then first, and I'll still have a true definition. So if I have congruent triangles, then all pairs of corresponding parts will be congruent. Or I could say if all pairs of corresponding parts are congruent, then I will have congruent triangles. Likewise, a congruent polygon is a polygon that has all pairs of corresponding parts congruent. Or if all pairs of corresponding parts are congruent and the figure is a polygon, then I would have a congruent polygon. Now looking at proofs, from now on, instead of using conditional statements, so if then, we'll refer to most theorems and postulates by the names or abbreviations that are assigned to them. So in my reason column, I can just have addition property or subtraction property, multiplication property, division property, substitution property, or transitive property. Any property that we learn from now on, we can just state that property. Now we can also refer to definitions as definition of whatever definition we have. So instead of the conditional statement for, let's say, angle bisector, if a ray bisects an angle, then it splits the angle into two congruent angles. I can just say definition of angle bisector. Now looking more at correspondence, notice that I have triangle KIT and I reflect it along line segment KT to give me triangle KET. Notice that angle I reflects onto angle E, angle 1 reflects onto angle 2, angle 3 reflects onto angle 4, side KI reflects onto side KE, and side IT reflects onto ET. So when I reflect, this would give me congruent triangles. Notice that we just had 5 different corresponding parts. I'm missing that last corresponding part. Notice the corresponding part is side KT with side KT. It's a shared side. Whenever a side or an angle is shared by two figures, we can say that the side or angle is congruent to itself. We will say this by using the reflexive property. One of the most important properties when we're trying to prove congruent triangles is the reflexive property. So the reflexive property is any segment or angle is congruent to itself. Now looking at the reflexive property when I'm talking about two angles, notice I have two triangles here, but they're overlapping. So I have triangle STQ, and then I have triangle PQR. Notice that angle PQR and angle SQT are two names for the same exact angle. So I can show that these angles are the same by using the reflexive property. Now looking at a few sample problems, I want to try and justify each conclusion with one of the properties presented in Chapter 2 and in this section. So looking at problem 1, I'm given the following givens, and I want to conclude that angle ADC is congruent to angle ABC, line segment CM is congruent to line segment AN, line segment BD is congruent to line segment DB, and line segment DC is congruent to line segment DB. So let's look at A. Angle ADC is congruent to angle ABC. So ADC is this angle, and ABC is this angle. Notice ADC and ABC are made up of angle 1 and angle 2, and angle 3 and angle 4. I have that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. So if I add congruent angles to congruent angles, then their sums will be congruent. So I can state that angle ADC is congruent to angle ABC by the addition property. Now looking at part B, line segment CM is congruent to line segment AN. So this line segment is congruent to this line segment. Notice I have double midpoint, and then line segment DC is congruent to line segment AB. So I have my holes congruent to each other, and I have double midpoint. Whenever I had double midpoint, I would use either multiplication or division. I'm going from a larger segment to a smaller segment, so I could use the division property. If segments are congruent, then their like divisions will be congruent. Looking at C, line segment BD is congruent to line segment DB. So this is a shared segment, the same exact segment. This would be the reflexive property. And looking at part D, I have line segment DC is congruent to line segment DB. So line segment DC congruent to line segment DB. Now notice I have line segment DC congruent to line segment AB and line segment AB congruent to line segment DB. So since this is a flow of congruences, I would use the transitive property because I will take line segment AB and replace it with line segment DB to give me line segment DC is congruent to line segment DB. Looking at problem 2, I have the following givens, and I want to make the following conclusions. So looking at my first conclusion, I have angle QFG is congruent to angle RGF. So that's this angle here congruent to this angle here. In my givens, I'm given that angle 5 is congruent to angle 7, and I'm given double angle bisectors. When I had double angle bisectors and one piece congruent to another piece, I used either multiplication or division. I'm going from a smaller angle to a bigger angle, so I'm going to use multiplication. If angles are congruent, then they're like multiples are congruent. So angle QFG is congruent to angle RGF by the multiplication property. Looking at B, I have line segment QP is congruent to line segment PR. So this segment congruent to this segment. Notice in my givens, I have line segment QG is congruent to line segment FR. So my two whole segments are congruent. Then I have line segment PF is congruent to line segment PG. So my two smaller segments are congruent. So if I were to subtract these two smaller segments from my larger segments, I would get line segment QP is congruent to line segment PR. So part B, I can use subtraction property. Part C, angle 7 is an acute angle. Notice that I have angle 5 is an acute angle, and then angle 5 is congruent to angle 7. So I can use the substitution property to replace angle 7 with angle 5 to state that angle 7 is an acute angle. So C is substitution. Then looking at part D, I have angle FER is congruent to angle GEQ. So this angle is congruent to this angle. Notice that they are overlapping triangles and they share that same angle. So this would be the reflexive property because it's a shared angle. In this lesson we learned congruent figures have the same size and shape. Congruent statements tell me which angles and sides correspond with one another, and the reflexive property states any segment or angle is congruent to itself. That's a wrap on this video. We'll see you in the next one.